Hello, I'm Ruhun, and this is my Physics 2212 Lab 2. The purpose of this lab was to, again, observe the interaction between two charged U-tapes, um, and to determine the charge of the U-tape by observing this interaction. But this time, as opposed to lab 1, we will model the tapes as a uniformly distributed charge rather than as a point charge. So the results from last time was the tape had a positive charge. The charge of the tape was 2.068 times 10 to the minus 8 coulombs. And the tape was deficient. And so from this, we could deduce that the tape was deficient in 1.29 times 10 to the power of 11 electrons. So in this lab, we used some important physics principles. We used Newton's second law for like gravity, Coulomb's law, the gravitational force, and also the uniformly distributed charge E field formula. So yeah, my assumptions for this lab was that the tape is treated as a uniformly distributed charge. Air resistance is ignored, and both tapes have the same amount of charge. So the initial conditions were the length of the tape, 0.17 meters, the width of the tape, 0.019 meters, the mass of the tape, acceleration due to gravity. And the system was the two pieces of U-tape, and the surroundings was the earth, my hand, and the surfaces. So the procedures of this lab was exactly the same as lab 1. So you just get two U-tapes and stick them together, rip them apart, then observe the interaction between them. So the observations from that lab was that the two U-tapes repelled one another. However, the U-tape attracted a neutral hand and a negatively charged pen. Therefore, the U-tape was positively charged, and the separation distance between the U-tapes was 0.02 meters. Here was my coding for it with all of the constants, the E field function, and tapes. Some more coding from the charge of the tape and also the force arrows. And then here are the results. There's the image that that it gave me, and you can see that the magnitude of the electric force was 1.667 times 10 to the minus 3, and the magnitude of the gravitational force was, well, the same in the opposite direction. So the charge of the tape was 2.068 times 10 to the minus 8 coulombs, and this actually differs from the charge calculated in lab 1 by about half the magnitude. Yeah, so the possible sources of error is neglecting air resistance, which could decrease the magnitude of the charge, inaccurate measurements of distance and lengths, and also the Hell tape was not perfectly parallel to the U tape. So, what if you had modeled each of your tapes as a single point charge like in the previous lab? So, if the tapes were modeled as a point charge, the value of forward charge would have been less than the value calculated by this experiment. Uh, yeah, so, and then why do these estimates differ? Which value is more likely to be closely provided by? So, the rod charge formula takes into account the length of the rod and how the distance of the rod to the observation point isn't constant. And the line charge value is closer to the value because the tape is more like a line charge than it is a point charge. And yeah, that's the end of my presentation. Thanks for listening.